All right, so yes, SEPTA is a bit of a mess today. So we are getting started at 9:38. 9:38 or so. First things first, let's boot up IntelliJ and go over the 100% solutions for the Fox and Rabbit, and then I'm going to go over a bit of assignment 2. I'll explain which problems I'll also do in class. Yes, what problem I'll do in class. In both Lab 2 and in Lab 3, I will be doing a batch of those assignments, not batch, but like some of the sub-problems in class because they are worth going over. In those cases, today I'll be going for Lab 4 and 5. Not Lab 4 and 5. For Lab 2, I'll be going over the second to last one in class. And for Lab... the second and last one? I'll double check. And then for Lab 3, I go over problems 3 and 4 in class because unless you've done Calculus 2 and converging infinite series, or convergences and divergences, you're not really going to be expected to be able to get that right. It's just the way it is with also teaching a group of students. So on Thursday not this Thursday, but next Thursday, I will be doing a couple of proofs in class. Nothing you need to know for an exam. I will be doing a visual, not really a mathematical proof, but it will make total sense kind of deal, as well as a formal proof by induction, because it's a pretty neat trick to see. All right, Fox and Rabbit first. All right, so Fox and Rabbit, the rules I gave out in class were that you could, I try to be very specific with my language. So the rule I gave is that you can only modify the Rabbit class. Occasionally, I do let students modify the grader, but only in one sense, which is to bump this up by a couple digits to make sure that it's more consistent and less swingy with the luck, if they really are worried about being unlucky. But with this, I say you can modify the Rabbit class. And I do mention that basically all your work can be done in decide move, but it doesn't have to be. The main thing is that the model view controller means that you've got basically this idea of how the class works. Now, I don't know why you get past the model of the class as an argument, but you do. Now, it is a private variable, meaning that if you decide to access it over here, like to say model game is over, you're going to get a false. But model does have a number of useful traits, such as saying, hey, here's how big this thing is, and you can't modify these private variables even if you have access to them. Okay, but there's a number of things with default access. Default meaning that if you are in the same package, you can change them. That's almost the same as public. For the intents and purposes of programming, for being a developer, that is the same as having public access if you're working in the same package. Default right public versus private, right? And then there's also protected as well, but we don't really need that. The important thing is that if you are, right, in the same package is effectively public. Default is just leaving off any kind of identifier on it. So, Rabbit is alive, game is over, number of steps taken, right? Rabbit's turn. All these kind of things that we use here. We can access these because they're static, right? Meaning that they aren't tied to a particular model or instance of a model. But if we can have access to this model, we can do things with it and manipulate it. And that's exactly what the way to cheat is, which is and you're going to laugh at this, which is first off, you can't put anything in front of a super. That just doesn't work. When you do a constructor, the super is always called by default and is always called as the first thing. So I can't even put a sout here, I think. Oh, apparently I can. I thought it would be the first thing that was called. But if I do model dot game is over equals true, yeah, now it yells. No, it doesn't yell at me. Okay, I'll go ahead and say and run it with the grader, and we'll see that basically. Hopefully this works. That I escape all the times because the game is over as soon as I begin it. Now you see why I only honor it for the first student who sees it, because it would trivialize the entire assignment and basically pass through the class like wildfire if I let everybody do it. So I find it for the first person who thinks sideways. It's always kind of good to think sideways, especially if you want to do any kind of work in security. You need to be able to think sideways like that. Most cryptographical attacks are not necessarily if they're not broken by this kind of sideways thinking math and doing some weird math tricks, they're broken by doing by attacking the people, not the code itself. So, for instance, man-in-the-middle attacks. You know, when people's stuff get hacked or they lose their personal information, it's because they, install a bad executable or they're dealt with the pressure of stuff. And it's easy to condemn people or think they're stupid or stuff. But the thing is that attacker only has to get lucky once over a wide variety area. And for you to not fall something, you have to not fall something for your entire life. That's not going to happen. You're going to fall for something eventually, and that's okay. The main thing is being able to figure out how to mitigate those kind of disasters when they happen. But that's a separate story. Sideways thinking allows you to kind of think about these attack vectors a bit more. Okay? Now, let's talk about the upcoming assignment. So hopefully you've watched the Arraylist videos today, in preparation for today. If not, go ahead and take the chance, tonight to watch these over. This is the typical way that it's going to work. I'm going to have these videos, and I will mute them for right now, but you'll see that we've got these videos. This introduction is like 2 minutes long, and then I've got my green screen set up.
So generics exist to solve.
And it's literally just like a pop-up green screen I've got behind me that I've chroma keyed for this kind of stuff. That the campus was that the school was was kind enough to pay for. And you'll see that some of these, I try to keep these fairly short. Like this is 16 minutes. That's on the longer side.
So this
one is 9 minutes long. And then we'll see that this add method.
So that was humiliating. I just lost 40 minutes of recording because I forgot to mute, or rather unmute my microphone.
Happens more often than you think. So this is a 17-minute video. But you'll see that basically I try to keep it below 20 minutes. The rule of thumb is that 1 minute per grade level for what you're making for each video. So sophomore, I guess we'd call this 14 minutes, right? We're trying to target here. So, but it's all less than 2 hours. And I know you've messed with the Arraylist before, so even without watching the videos, you should be able to take a good crack at these. So let's go ahead and take a look at these list functions. All right, the trickiest part of this will be working with generics. Okay, generics are a required part of the assignment, and I'll be using generics throughout the class. I go over in detail on these PDFs about how we use generics, which is simply to say that, hey, we've got a public. What we're doing over here is that if we declare a static method like this, we're saying basically public static. We'll come back to this in a second. Boolean in, which is testing if an item is in this list, right? This is a fact. I know it's built in with the .contains method if you watch the videos, okay? But this is just basically if I needed some example, okay? Here we have a list list. A list is an interface, but that's okay. This just simply means that it could be any type of lists, and there are multiple types of lists. This week we're working with array lists, okay? This less than E greater than, or angled brackets, this E in between these angled brackets basically denotes that this is a list of something. And more importantly, this defines that all those somethings are all the same type. Basically, we're saying it's a list of integers, or it's a list of strings, it's a list of something, okay? The most generic being objects. It's being a list of objects. This is useful because you can totally, so this is useful in two ways. The first is that you can assume that they're all the same type. When we're writing this, we can make these methods you'll see later on, we can modify this method, this part specifically to say that this is a specific type of object. So maybe they're all comparable objects, or they're all some kind of subclass of something. Another useful type, though, is notice that we don't have that E there because we don't need to define what this is, right? That's the biggest mistake I see students make, and I'll help you correct that if you make it. Public static, whatever the return type is, my method, list of integers. This is great because this method now can assume that the list only has integers. We don't have to cast it. We don't have to we don't have to basically specify, or we don't have to make an if statement to check if the item is an integer. The list and the Java compiler will enforce that this is an integer. If this is a complete alien speak to you and you have no idea, there is a video in the playlists about lists and generics over here.
So generics exist to solve.
And it's only 16 minutes long, so you'll be able to watch it, and it goes over why we need these things, why these things are important. That's why I'm not going to spend too much time on them. And then you'll have a quiz on that material there. Again, these quizzes should be unlimited retries. If they're not, let me know. But they should have a 15-minute lockout. Okay. Going back to this, basically the entire point is do we need do we need this method to work on a list of any type or just a single type? So we've got 6 methods here to write. This is unfortunately busy work, but it's good busy work. For each of the following, we are going to be creating a static method with the appropriate inputs and outputs. We want to call them each with the main method just to ensure that they're running. This is one of those, oddly enough, that I'll be able to tell if your code works just by looking at it, and because these are fairly short methods. You're allowed to solve them however you want, although I will mention that that for Lab 3 you will be analyzing your own code in terms of runtime performance, which I'll help you do. And unless you do something extremely exotic, which generally means relying on ChatGPT for help, then you shouldn't have an issue with it. Uniqueness. Write a method called unique, which takes in a list and returns if all the items are in the list are unique. So none of the items being the same. So here you want to assume that everything is unique until you find a match. If you find 2 objects, 2 items in the list that are the same, then I would return false. So with these Boolean stuff, like checking if something is unique or not, like anything method that returns true or false, it's always easy to assume that if assume that it's going to be true, put that at the end. Or assume something that will always be true or false, and then do a loop to prove by contradiction, essentially, or disprove by contradiction. Let's go ahead and actually kind of show you how that. So the way that kind of thing the way this would look. Let's go ahead and just make a Java class called my Arraylist HW for my Arraylist homework, right? Okay. The way that would look: public, static, E, Boolean is unique, list E list. All right, let's go ahead and fix those import issues. Import class, it's java.util. And again, like I said, all I'm going to do is just by default return true. I'm going to assume everything is true I'm going to assume this is going to be true until proven otherwise. Now, why do I bother with this whole generic nonsense? Or it looks like nonsense, or it looks like overcomplicating things. If I don't include this, notice that we get a warning, just simple a yellow highlight. And it's just going to say, it's just a boring warning. Should give me a boring warning. It says, inspection, raw use parameterized class option. Click to edit. So this is basically saying, hey, that this should be using a generic. And since you're not using a generic, we're going to have to do that for you and make it take in an object. This is going to give you, if you don't use generics, you're going to get a boatload of warnings because it's not the intended use of this. But I think it's partially kept in, that warning is kept in and made not an error for backwards compatibility all the way back to like 2006 or so. So we've got this. It's going to look like this, and essentially you'll do some kind of for loop. Possibly a nested for loop. Okay. Problems 2 and 3 are very, very similar. All multiples and all strings of size. All multiples takes in a list of integers and an int. It returns a new list of integers that contains all the numbers from the input list that are multiples of given int. I've got this example here, and I'm given 5. And so we return 25, 5, 30, and 25. 25, 5, 30, and 25 because they're all multiples of 5. We don't bother checking, as you can see with the repeated 25. I'm not asking you to do anything complicated by like double check, like for checking to see if there's duplicates or anything like that, right? There's 2 25s in the output because there's 2 25s in the input. Okay, and that's going to look quite different. It's going to look like this: public static list of integer. We all multiples. I'll explain more about this in just a second. List of integer. List int I. Okay. And then I'm going to just simply create a, you know what, I'm going to let you create your own list there. I'm just going to return null here because I wanted to just stop, because I am pathologically unable to keep code in front of me if it has an error, right? I've got to make sure that the error is quashed or in some way can compile. So, first off, you'll notice that there's a lack of brackets like right here between this and the return type, right? I don't do a integer over here. Notice that if I do an integer here, it changes the color of these integers. Very subtle, right? E and integer to makes them all green. And the reason being is that what you're doing over here is you're saying that if I create an angled bracket thing here, I'm saying, hey, there's going to be a generic type here. I'm going to put a symbol here, rather, that represents the generic type. Think of it as a variable for a class type, okay? And so what I'm saying here is that the integer is not actually an integer, but this is a variable called integer. So when I try to do stuff like add things together, it's going to get very confused, right? You'll see for a second that that if I do something like this, int a is equal to list.get 0 or 9 or whatever, it's going to give me an error because it's like, hey, you can't convert these two things. Well, got back up a second. What the heck is an integer? An integer is what we call a wrapper class. every single class, every single primitive, like double, okay, double D, has a wrapper class, assuming I can spell them, because occasionally you need to treat the primitive as though it's an actual object, right? Primitives are just data. Objects have all these additional powers you can give them. So here, right, we've got the primitive and we've got the object. And for most cases, you can use either or because Java's awesome like that. In fact, you can do stuff like this, right? 5.0, and then double D is equal to D, and it will do what's called auto boxing or auto unboxing and convert one between the other. And notice that as soon as I deleted this generic marker over here that I said don't put in, this works. It says list.get9 because it knows it's an integer at index 9, and because only integers are in this list. And it basically took that integer class and turned it into a primitive, no problem. So why don't I just cut out the middleman and make it take a list of ints? And the answer is you can't, unfortunately. It's stupid, in my opinion, and I'm sure there's very good design reasons for it. Okay? There's a few things about Java I do find very stupid. This is one of them, but I'm sure there's a sensible design reason. You cannot put primitives as generics. So you have to use the wrapper class if you want it to be a list of integers, right? Now, if you do this on a test, right, where you put in a list of integers, an int, that's one of those things where I'm like, that's a 1-point mistake because your compiler would normally yell at you and you'd be able to fix that pretty much instantaneously. Okay? I can't not penalize. I mean, I could not penalize it, but honestly, it's like a 1 point on a 100-point testing isn't really going to matter in the long run of things when I'm penalizing specifically on that. But again, so list of integers over here. This specifies that we're going to be taking in a list and it's only going to take integers, and that our output is only going to take integers. Okay? So that's pretty nifty. 23 is very similar. All strings of size, which we parse a string and get all the strings of a certain size from it. Okay, is permutation 2.4. This is part of the reason I go over this. 2.4 I will go over on Thursday. I would like you to try a hand at it, try to solve it yourself. Right? This one specifically, I'd love it if you try to solve it yourself, but if you can't solve it yourself or you find you're banging your head in the wall in frustration, don't fret. I will go over this one on Thursday because it is a pain in the butt. There is no way to not do this in a way that doesn't look hideous. Okay? Especially with what you know now. With what you know now and not knowing about things like hash maps, this is just going to look ugly as hell. Okay? String to list of words. This one has an extra credit attached. Basically, what we're going to be taking in is a string and converting it into a list of words. Right now, for the regular credit, you get to assume, okay, it just simply has, for extra credit, almost got the error. So we can assume that every word is basically separated by white space. That's all this means. Basically, if you see a space, that's how we tell one thing is a word versus another word. So if our input string is hello world, our output should be hello, comma, world, exclamation point. For extra credit, you're going to sanitize that string so that my output would be hello world, right? None of the punctuation. Okay, that's a bit trickier. That's why it's extra credit. Make sense? So, and the nice part is you can start here at the regular credit and then go here to the extra credit. Now, final one, 2.6. Remove all instances. This is one you have to do yourself and figure out yourself. Basically, what you have to do is say you're given something like this, and say we want to remove all 5s from the list. So notice this has 1, 4, 5, 6, 5, 5, 2, and we want to remove all the 5s from it. It's very important that you try this on the input, on my input, okay? You gotta test it on my test case. Otherwise, you might be led astray, okay? This one is definitely one of those where you program it, okay, and then you realize, oh crap, I just fallen into a trap, okay, and then you got to work your way around that trap, okay. There's actually a few different traps depending on how you try to program it. Now, since there's a few different headaches, there's also few different solutions. I would say there's probably 5 different solutions, three of which are done by the majority of the class, and then 2 which are done. One which is accomplished by either having a very deep knowledge of Java or relying on ChatGPT and learning about predicates, and then finally one which is absolutely deranged but absolutely performant as opposed to the other solutions. It's funny how that works, where the absolutely deranged one is the most runtime efficient. It's not even complicated. It's just dumb, but it works so well. Anyway, what we will do when you demo is that we will ask you about this one specifically and how you solved it. No matter how you solved it, I will be going over how some other alternative means of solving them. So don't feel like I'm calling you out, like your solution was bad or anything. No, it doesn't matter what your solution is. I'm going to be showing you other solutions so you know what they are, okay? Because I want you to have those tools in your toolbox, okay? Just could sound like I'm judging you heavily, and I'm not. I'm telling you those solutions because you deserve to know them. And then we'll be going, so when you demo, you're going to be demoing this one, and then any other one I choose, okay? So just 2 of them, pretty much. All right. 10 points for making sure your code is neat and properly indented. So I'm going to call you out if it's not and give you the chance to fix it. And then again, it's worth 5 points to make on each problem to make sure you're using generics. So that's a pretty heavy hit if you don't use generics. All right. So once you're done with that, I just want to make sure because we will have students who are going ahead. Once you're done with that, Module 3, which is next week's stuff, is a math worksheet. I also have to double check that the due dates are sane for this, so give me a sec. January 28th. Yeah, that's sane. Okay. Because I knew that I'm having some issues with 1051. So the other one, our Big O exercise, is a math worksheet. You can print this out and write on it. You could write on it electronically. You can convert it into a Word document. You can just simply have a sheet that says 1, answer, 2, answer, 3, answer. I don't care how you do it, okay? Unlike normal math homework, I'm going to be going over this with you, and if you get them wrong, I'm going to tell you what you need to fix so you can go back and make sure you get 100 on it, okay? So if you're done with that you know what to work on next. All right, so with that, I'm going to go around the class and help everybody out. Stop recording.